This is video 8-2, the types of reactions. Okay, now, from the last video, hopefully you went and copied these and balanced these, so here are the answers that you should have. Okay, you can pause, check it, and move on when you're done. Okay, now, types of reactions. Okay, 5 basic types of reactions you need to know about. Okay, so the first type is something called a synthesis reaction. Sometimes it's called a composition reaction. Sometimes you'll be see it called a combination reaction. Okay, but basically, what happens? You have 2 or more reactants, and they make only one product. And obviously, the product has to be a compound. Okay, so X and Y, these could be elements. They could be compounds also. But what identifies it is that only one product. Okay. And simple one, sodium combines with oxygen. Okay, so sodium plus oxygen, don't forget oxygen is diatomic O2. Now, how do you figure out what the product should be? Well, that's a metal, that's a nonmetal, right? So that means it must be an ionic compound. So ionic compounds, figure out what your ions are. We have Na plus, and oxygen goes to O2 minus. Okay, crisscross your charges. So this should be Na2O. Okay, last thing you need to do, balance it. So balance the oxygens first. Put 2 there, so you have 2 oxygens, and that means you need 4 sodiums. Okay, so here's your balance equation. Second type of reaction is something known as decomposition. Okay, this is pretty much the opposite of a synthesis reaction. You start with only one reactant, and you have to have 2 or more products when you're done. Okay, the products could be compounds, they could also be elements. Okay, now, to run a decomposition reaction, often you're going to need to add some heat to the reactants or electricity. This is called an electrolysis reaction to get it started. Okay, so you have to start out with a compound and only one, and you get 2 or more substances. Again, they could be elements or compounds. Okay. Example, an electric current is run through water. Okay, so water, H2O, okay, and we need to indicate that we're putting in electricity. So we can put, say, electricity over here. Okay. Now, what are you going to get? Well, pretty much you have H2O, H2 and O2. Okay, hydrogen and oxygen. It decomposes into its elements. Next thing, balance it. Okay, I only got 1 oxygen on the left, so I need 2 of them. And that gives me 4 hydrogens on the left side, so put a 2 there. That'll give you 4 on the right. Okay, next reaction, known as a single replacement reaction, or sometimes it's called a displacement reaction. Okay, now, 2 reactants, 2 products. Remember that on this one. One of them has to be a pure element, and the other reactant has to be a compound. Okay, now, what has to happen? The metal can only replace a metal in the compound. Or if your pure element is a non-metal, it'll replace the non-metallic element in the compound. Okay, so basically it looks like this. This is your pure element. This is your compound. Okay, as long as X and Y are metals, X will replace the Y element here in this compound. Okay, Y becomes the new pure element. X turns basically into an ion and forms an ionic compound. Okay, or if X is a non-metal, then it's going to replace the non-metallic element in the compound here. Okay, and this, the Z, becomes your new non-metal, your new pure element, and X becomes basically an anion in this compound here. Okay, now, one thing you have to do, okay, on your sheet that's in your handout in your packet, okay, types of reactions, you can use this on the test, but you have to know how to use it. Okay, for single replacement reactions, X, the pure element, has to be more chemically active than what is trying to replace, the one that's in the compound. Okay, otherwise, no reaction can take place. In other words, if X reacts with Y and Z to produce Y plus XZ, this reaction cannot take place. Y plus XZ produces X plus YZ. Okay, X is trying to replace Y, Y is trying to replace X. Only one of these reactions can take place. Okay, so if X can replace Y, that means Y cannot replace X. So this reaction would not be able to take place. Okay, how do you know? You check the activity series, okay, on the handout. If X is more active than Y, then the reaction takes place. So let's take a look at this reaction. Barium chloride reacts with sodium. Okay, now write out our formulas. First one, barium chloride, no prefix, so that means it's ionic. So you need to know your ions. Barium, Ba2+, column 2. Chloride, column 7, so it's a -1 charge. Balance your charges, and you have BaCl2. Okay, going to react with just sodium, and this is pure sodium, so it's just Na. Okay, now you need to check the activity series, okay, and be careful. It's not the first one that you see trying to replace the second one. It's always the pure element, which could be written second, trying to replace the one that's in the compound. Okay, so pause the video, check your sheet. Is sodium more active than barium? Okay, so you should have found out that sodium is not more active than barium. So basically that means NR. What does NR mean? No reaction. Okay, so this reaction will not take place, so not replace the barium. Okay, well, let's take a look at this one. Lithium reacts with barium chloride. Okay, so we can write out our reaction. Li plus, we know barium chloride is BaCl2. Okay, now go and check, pause this and go and check your activity series. Okay, you should find that lithium's at the top, which means lithium pretty much is going to replace anything. Okay, and it has to replace the metal. So what happens? The barium, which was actually Ba2+, now turns back into pure barium. The lithium has to turn into its ion, which is column 1, so lithium 1+. It's still going to react with the Cl-. Okay, so this becomes LiCl. And last thing, balance it. 2 chlorines, so put a 2 there, gives you 2 lithiums, put a 2 there, and this is your reaction. Okay, one more. Fluorine reacts with barium chloride. Okay, now fluorine, don't forget, this is diatomic. Okay, halogens. Reacts with barium chloride, so BaCl2. Okay, pure element is going to replace the compound, but fluorine does not replace the barium because it's a nonmetal. The fluorine is going to try and replace the chlorine. Okay, but again, you have to check the activity series. Okay, so pause it, check the activity series on your sheet. Okay, it's on the front side below the long list of metals. Okay, and notice it's easy for you to memorize the activity series for the halogens because it's basically top down. As long as this one's above the one it's trying to replace, it's more active. Okay, so will fluorine replace chlorine? Yes. Okay, so your new pure element is going to be the chlorine plus the fluorine has to turn into F1-. Okay, it's going to combine with Ba2+ again, and you're going to get BaF2 for this one. Okay, now double replacement reactions. Okay, aqueous ions, that means the substances have to be dissolved in water. Okay, for 2 compounds, so 2 reactants, both of them have to be compounds. They will exchange places to form new compounds. Okay, now one of the products has to be either a gas, a molecular compound, or precipitate. Okay, otherwise no reaction takes place. Okay, now you can assume in this chapter that one of the products, as long as you know it's double replacement, will be one of these 3 things. Okay, so what's happening? AB reacts with XY, and you have AY and XB. Okay, now what's taking place? In one container you have AB, but because it's dissolved in water, it's actually going to exist as ions. So let's say it's A+ and B-. Okay, in the other container you have X and Y, but they are also dissolved, so they break up into ions, X+ and Y-. Okay. Now, one of these things, AY and XB, Okay, and it cannot be AX because notice A is positive, X is positive. They can't combine. Neither can the B and the Y. Okay, now one of these things has to actually stick together. Okay, if you put them into solution and neither of these stick together, in other words, you have A plus, B minus, X plus, and Y minus. None of these combinations is a gas, a precipitate, or a molecular compound. Then basically no reaction took place because you had 4 ions when you started. If you have the exact same 4 ions when you're done, no reaction took place. Okay, so aqueous solutions of sodium chloride and silver nitrate are mixed. Okay, so again, write out your formula. Sodium chloride, okay, this is going to be Na plus with Cl minus. Silver nitrate, silver ion, you got to memorize that one. It's Ag plus nitrate, NO3, 1 minus. If you don't have these memorized, better go back and memorize them really quickly. Okay, so your compounds, NaCl plus AgNO3. Okay, now what's going to happen? The Na is going to combine with the NO3. The Ag is going to try and combine with the Cl. You have to always write the cation, the positive one, first in the formula. Doesn't matter which compound you write first, but make sure you write the formulas correctly. Okay, so AgCl plus NaNO3. Everything's minus 1, so you don't need to crisscross any charges. Okay, now, you don't need to know this for this chapter, but it'll come back later on. Okay, one of these is going to be a precipitate. Which one's the precipitate? This one here. Okay, how do you know? Well, memorize a couple rules. Okay, any nitrate compound is always soluble, meaning it can never be a precipitate. So this one right here has to still exist as ions. It's still basically Na plus and NO3 minus. Okay, the AgCl sticks together, so this is a precipitate. So you could actually put the arrow going downward, or you can write an S afterward. Okay, combustion reactions. Okay, in a combustion reaction, it is a reaction with oxygen. Okay, so when someone tells you it's a combustion reaction, you have to add oxygen to it. Okay, and it releases heat and or light. In other words, it's going to burn or it explodes. Okay, just because it reacts with oxygen doesn't mean it's combustion. You have to get these things as products also. Okay, so 2 basic types of combustion reactions to remember. Hydrogen plus oxygen gives you water. Okay, and also you're going to get heat. Balance it. You need 2 O's, so 2 there, and you need 2 more hydrogens for a total of 4 on both sides. Okay, another combustion reaction that takes place is carbon. Carbon reacts with oxygen, gives you CO2 and heat. Okay, now this is called complete combustion. Okay. An incomplete combustion reaction basically means carbon reacts with oxygen, but you get, instead of carbon dioxide, you get carbon monoxide. Okay. Now, unless you are told otherwise, and remember this, okay, always assume it's going to be complete combustion. The only time you're ever going to write it as CO is that it is incomplete. Okay. Now, what happens if you burn something that has both hydrogen and oxygen? Simple. This is known as a hydrocarbon. Okay, it has hydrogen and carbon in it. You get CO2 and H2O. Okay, anytime you burn carbon, you get CO2. Anytime you burn something with hydrogen, you get H2O. Okay, plus heat. Okay, so try these. Copy these down. First thing you do. Second thing, classify what type of reactions these are. Okay, and then the third thing, complete the reactions. Write out the formulas of the reactants, write out the formulas of the products, and balance it. Okay, so copy it and classify what it is, then come back. Okay, so how do you figure out which one is which? Well, this one's pretty simple. If you have an element and an element, it's going to be a synthesis reaction. Okay, so basically metal, non-metal, turn them into ions, figure out your product. Okay. Next thing, hydrochloric acid with sodium hydroxide. This will be ions, this will be ions. 2 compounds. This will be double replacement. Okay, third one, calcium carbonate is heated. Okay, now only one reactant. That means this is going to be decomposition. Okay, next one, methane is burned. Okay, right here, they tell you burning, it is combustion. Now, they don't tell you you only have one reactant. Okay, methane, this is one you should remember. CH4, that's a formula for methane, some common compounds. Okay, so it's burned, so you have to add O2 to it. Don't forget, anytime you figure out combustion, add oxygen. They're not going to tell you to do that. Okay, next one, iron plus cupric chloride. Pure element, compound. That makes it single replacement. Before you go on, make sure you check the activity series. Okay. Next one, plumbous nitrate and potassium chromate. Okay. Ionic compound, ionic compound. Two reactants, both compounds. This is going to be double replacement. Okay. And the last one, hydrogen plus nitrogen, element, element. That makes it synthesis. Okay, so figure out, write the formulas for these reactants, figure out what the products are, and we'll go over them in class. The review question, which of these reactions will not produce two products?